Welcome to a webcast produced by the Learning and Enhancement team based in the Dean of Students office at the University of East Anglia. This webcast is part of the Steps into Numeracy series and concerns prime factors. This guide introduces the common mathematical ideas of factors, prime factors and prime numbers. It also describes two methods for the prime factorisation of whole numbers. Introduction. Different types of factors. The factors of a number are the whole numbers that are multiplied together to give that number. Sometimes the word divisors is used instead of factors. Working out the factors of a number has many uses. For instance, in the simplification of fractions and factorisation of algebraic expressions. See study guides, Cancelling Down Fractions and Simple Factorisation. For example, 1 multiplied by 16, 2 multiplied by 8 and 4 multiplied by 4 all equal 16. So the factors of 16 are 1, 2, 4, 8 and 16 itself. In mathematics, the word proper has a specific meaning. The proper factors of 16 do not include 16 itself and so are 1, 2, 4 and 8. The list of factors can often be broken down further into a list which only contains prime numbers. These are called the prime factors of that number and are usually written in ascending order. The method for finding prime factors of a number is called prime factorisation. Prime numbers. In order to work out the prime factors of a number, you need to know whether each factor is a prime number or not. The definition of a prime number, commonly called simply prime, is a prime number has just two factors, 1 and itself. The first 9 prime numbers are 2, 3, 5, 7, 11, 13, 17, 19 and 23. Importantly, 1 is not a prime number as it only has a single factor, 1, which is also itself. Just as importantly, 2 is the only even prime number. This is because all the other even numbers have 2 as a factor and therefore cannot be prime. A list of all the prime numbers less than 1,000 is available on the fact sheet, Prime Numbers Under 1,000. All the whole numbers, apart from 1, which are not prime, are called composite numbers. Each composite number is made by multiplying together a unique list of prime numbers. This fundamental idea is called the prime factorisation theorem by mathematicians. It was known as far back as Euclid, about 300 BC, and remains true today. In fact, if the prime factorisation theorem was not true, none of the strategies in this guide would work. Strategies for finding prime factors. The most effective way of finding the prime factors of a composite number is to have a good knowledge of the prime factors of smaller numbers. This is especially true if the composite number has 3 or more digits. So, a good initial strategy is to concentrate on finding the prime factors of small numbers, ones with 1 or 2 digits. It is also important for you to be able to divide a number easily by another number. All strategies to find prime factors involve breaking down the number in question into multiplications of smaller numbers. Eventually you will be left with only prime numbers multiplied together. There are many ways to do this. This guide will concentrate on 2 common methods. The first method, division by ascending prime numbers, requires you to have good division skills, whereas the second method, factor trees, requires a good command of your times tables. Division by ascending prime numbers. The method of division by ascending prime numbers involves repeated valid division of the number you wish to factorise by the prime numbers in ascending order. A valid division results in a whole number answer. Some strategies to tell you whether division will be valid or not are given in the study guide, Rules for dividing whole numbers. Method of division by ascending prime numbers. The method involves dividing the number you have by the smallest possible prime number. This process is repeated on the result until you have a prime number. Let's do an example. Express 36 in its prime factor form. As 36 is an even number, we can divide by 2, the smallest possible prime number, to give 18. Expressed another way, 36 equals 2 multiplied by 18. What you have done is recognise that 2 is a prime factor, a factor which cannot be broken down any further. However, you still have a factor of 18, which is a composite number which needs to be broken down using the same method. As 18 is even, you can divide by 2 again to get 9. In other words, 18 equals 2 multiplied by 9. Write this underneath as follows. You know that 36 equals 2 multiplied by 18. You have just calculated that 18 is equal to 2 multiplied by 9. And so the 2 multiplied by 9 is written underneath the 18. Again, you have identified a prime factor of 2, but also a composite factor of 9. You now need to prime factorise 9, but as 9 is odd, you cannot divide by 2, and so move on to the next prime number, which is 3. You started off with 36 equals 2 multiplied by 18, broke 18 down into 2 multiplied by 9. Now write 3 multiplied by 3 beneath 9 in your list. As 3 is a prime number, you have finished factorising. All that remains is to write the prime factor form of 36. If you follow the above method, the prime factor form is shown to the left of the list of factors, as circled here. So, 36 equals 2 multiplied by 2 multiplied by 3 multiplied by 3. Let's look at another example. Express 63 in prime factor form. As 63 is odd, you cannot divide by 2. The next prime number is 3, which does divide 63 to give 21. So 63 equals 3 multiplied by 21. 21 is also divisible by 3 to give 7. As 3 and 7 are prime numbers, you have finished the factorisation. So 63 equals 3 multiplied by 21, and 21 equals 3 multiplied by 7. You can now circle the prime factors, which gives 63 equals 3 multiplied by 3 multiplied by 7. Factor trees. An alternative method for prime factorisation is using a factor tree. A factor tree is constructed for a particular number by looking for two factors which multiply together to give that number. These factors are written below the original number. If a factor is prime, then it is circled. Factors which are not prime are broken down in the same way as the original number, until all the factors are prime. Although this method is similar to the first method, it can sometimes prove to be much quicker. Let's look at an example. What are the prime factors of 120? 120 equals 10 multiplied by 12, so 10 and 12 are written below 120.
Saying what you want it to say.
10 and 12 are not prime. As 10 is equal to 2 multiplied by 5, 2 and 5 are written below 10. Also, 12 equals 2 multiplied by 6, and so 2 and 6 are written below 12. The prime numbers 2 and 5 are then circled. The only number left that is not prime is 6. As 6 equals 2 multiplied by 3, 2 and 3 are written below 6. 2 and 3 are prime and are circled. The prime factors of 120 are all the circled numbers in the factor tree. So 120 equals 2 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by 5, where the prime factors are written in ascending order. It does not matter if you choose different factors as your starting point. For example, you could have chosen 120 equals 2 multiplied by 60. The answer will be the same. Here's another example. What are the prime factors of 315? 315 equals 3 multiplied by 105. So 3 and 105 are written below 315. 3 is prime and so is circled. (105) is composite, as 105 equals 5 multiplied by 21. 5 and 21 are written below 105. The prime number 5 is circled. The only number left that is not prime is 21, as 21 equals 3 multiplied by 7. 3 and 7 are written below 21. 3 and 7 are prime and are circled. The prime factors of 315 are all the circled numbers in the factor tree. So 315 equals 3 multiplied by 3 multiplied by 5 multiplied by 7. Further guidance and information. If you have any further questions about numeracy or would like to discuss any other aspects of mathematics, you can talk to your lecturer or personal advisor or make an appointment to see a learning enhancement tutor in the Dean of Students office. You can telephone 01603 592761, email dos.help@uea.ac.uk, or visit our website at www.uea.ac.uk/dos/let. There are further resources on many other aspects of numeracy, mathematics, statistics and science available from the Dean of Students office and on its website. These include questions to practice, model solutions and webcasts illustrating essential skills. This guidance is one of a series on mathematics produced by the Dean of Students office at the University of East Anglia.